From here on, we would like to start the next session, Legacy of Sunshine Project, Challenges and Achievements. And we'd like to receive lectures from those who are involved in Sunshine Project. After the lectures, there will be a Q&A session based upon the questions submitted in advance. So the moderator will be asking your questions on your behalf. As the moderator, we have Mr. Professor Michio Hashimoto of Research Center for Advanced Science and Technology of the University of Tokyo to look back on the significance of Sunshine Project. In 1989, Professor Hashimoto joined METI, predecessor of METI, and based upon his experience in Sunshine Project, he is being asked to serve as the moderator. Now, Professor Hashimoto, over to you, please. Thank you very much. I am Hashimoto of the Research Center for Advanced Science and Technology of the University of Tokyo. I will be serving as the moderator for this session today. From on my side, in 1990, as a first social professional, that was my second year, and I was at the predecessor of AIST, and I was in charge of promoting technologies. And ever since, in regards to various renewables, I did some work, and I have been continuing that actually. As for the Sunshine Project, as a professional, it was a starting point for myself. So today, at the time already, who was already leading research and development, and for the past many years as authorities, they have been leading the industry development of Japan. I have invited us 3 speakers, and I'm looking forward to hearing what they have to say. So first and foremost, I'd like to invite Professor KUWANO. Professor KUWANO was successful in industrializing amorphous silicon solar technology, first in the world, and he served as the representative director, president CEO of Sanyo Electronics, as well as he has served as the PV tech. So now over to you, Professor KUWANO.
Thank you very much for introduction. I am KUWANO. So we're now celebrating the Sunshine Project 50 years, and with the persons from METI, NEDO, AIST. Thank you very much for your invitation to myself. I'm really pleased to be here and be given this opportunity. In the past 50 years, I have experienced through what Sunshine Project was about. So I'd like to share with you my experience. And also, we're now not at the end of the story for the renewable energy. As the director of the agency mentioned, that renewable energy need to be continue to be worked on in coming 50 years as well. Of course, from 50 years from now, I wouldn't be here. But I'd like to share with you the following. We made efforts, a lot of efforts in past 50 years, not just myself, but I worked with many of the colleagues. There are so many people in this room as well that who worked really hard. And I like to hand over the passion to the people of the next generation so that humanity can achieve carbon neutrality utilizing renewable energy as a result of the everybody's effort being made. So I'll talk about 4 points. So there has been a detailed explanation about the Sunshine Project, so I'm not going to go into detail about the project itself. But it was really good that we started this 50 years ago. It was good not just for the industry of Japan, but for the humanity, survival of humanity. This project was a big help. And second point. So, well, this is the streamline distributed online, so my pointer may not be visible on the screen. But a second point I like to talk about is contribution of Japan in R&D and also commercialization. And also, as Dr. Franco earlier talked about the global situation, I'd like to say that in Japan also renewable is increasing, and I'd like to talk about that. And the last point is about future, to encourage many people who are now involved. Can renewable energy really cover the world energy needs? That's another thing that I'd like to talk about today with you. So those are the 4 points I'd like to cover. So my pointer may not be visible to those who are participating online, but nonetheless, I'd like to move on. So as mentioned by Director General and Director of the agency at MITI, the project started because of the increase of the oil price. But looking back, the project was really a great one. It was a efforts made between industry, government, university, and it was the first large-scale project done in collaboration between industry and government and the university. 3 sectors worked in unity, and please remember that. That was quite significant. And in terms of the contents of project, I'd like to skip because the contents have been explained in detail already. But one thing I'd like to mention is that the number 4 here, hydrogen, is going to be very important going forward. It has been already worked on since 50 years ago. Japan was giving attention to hydrogen even 50 years ago. Now, moving on. So these slides are about history, as shown on the left-hand side photo. Many people went to shops to buy many things as a result of the oil shock. And unfortunately, 2 years ago, there was aggression against Ukraine by Russia started, leading to another energy resource war. I just want you to think in this opportunity about why renewable energy. I'd like you to revisit that question. So what in the red box here? So only in 1 hour, the solar energy reaching to the planet can cover the energy consumption for all human beings in 1 year. So that is a starting point. Just with 1 hour equivalent of the solar energy, the entire human needs for a year can be covered. And hydro, wind, biomass, all are because of solar. We can say that humans are being able to survive, live, act because of the solar energy. And using that solar energy is all about Sunshine Project. Now, with regards to solar power generation, well, first I'd like to give focus to solar power because Dr. Ushiyama is to talk about the wind, and Dr. Muraoka is to talk about the geothermal. So I'd like to focus on solar. So solar power. Well, first, use for the satellites. Today, we're taking advantage of satellites, but this was invented as an extension from the transistor. And in Japan, the solar battery was used for a lighthouse. And as shown in 1974, when Sunshine Project was started, please do remember this chart. At the time, in 1974, the cost for the solar power generation was about 30,000 yen per watt. At the time, there was a target to make the cost down to 100 yen per watt, meaning to make it less than 1%. That was quite a bold target. And that was possible to be set as a target because that was a national plan or national project. Now, many different solar batteries were worked on. And what survived is a crystalline silicon solar cells and like a hybrid type, like a thin film solar cells and perovskite solar cells. Those are the ones who which have survived to date. Now, second topic of my presentation. So, how much contribution has Japan made to the world? So, this is its history for over 50 years ago. And this has already been explained by the Agency for Natural Resource and Energy, so I'm not going into detail, but there were three key points at the beginning. From the very first, the project started. So early days of solar cells, and then second phase was the where electric power was started being used, and the third phase is where the global expansion of solar power generation was seen. So there have been three phases till today.
何事もですね、一挙に成功
Nothing can be succeeded overnight. For first period of the Sanyo project period, oil price was high, but price went down. So those new technologies were not able to be competitive against existing thermal power. So I'd like to understand to those who are in the new generation about the history that many companies withdrew. But what did we do as a company? Well, electric manufacturers. Well, we were electric manufacturers, so we decided to apply the solar power generation for electronic products. Conventionally, wafer are connected with a lead line to achieve a high voltage. But this way, well, for one thing, it didn't look good. So patterning started as shown in the lower part of the slide. Patterning was applied for a linear connection like IC or LSI.
集積型という
So this is called a integrated type. When we are to work on a perovskite, that we use this integrated type, and this type started in Japan. Before that, there was no such concept as integrated type. So when we are to work on the thin film, we have to resort to the integrated type because of the high latency. And then, as shown on the right-hand side, the calculation equipment was run by the solar power with a 3 volt of the power. For the power generation, we're not able to achieve the outcomes, so we decided to use for the electric devices. Still today, those products are being produced in Japan. This is an example of a company in Fukushima Prefecture. The production is still continuing. Now, national project continued, and in 1990s,
十数年経った時に
so after 10 some years, with the national project, the conversion efficiency kept increased. At the time, the ozone layer depletion became an issue, meaning global environmental issue was getting attention. And with that,
もっと変換効率を上げる方法はないかっていうので
to seek for even better conversion efficiency, there were new methods being taken. HIT, heterojunction with intrinsic thin layer. This is another outcome of the Sunshine project. This was outcome of a quite preposterous idea or out-of-box thinking. This is the hybrid amorphous silicon and crystalline silicon. That kind of thinking was unprecedented before. So like this, the crystalline was used as basis and amorphous was connected. So this is similar to grafting bamboo onto a tree. So this was a new approach of manufacturing a cell. So what was the outcome? Before that, as shown on the left-hand side, the crystalline silicon and impurity p-n junction was made, but with the amorphous the crystalline combined, new structure was made possible. This is quite a out-of-box thinking outcome. And then this slide is from the time we're able to achieve the world-leading conversion efficiency of 25% today. The rate is around 27 or 28%, but with this type, the records have kept being renewed. And that was about the cells. But with the cell alone, it's not going to be really leading to much use. And I'd like to now talk about the another application, which is the application for private residential photovoltaic system, which also has long history itself. Before 1990s,
電力村への接続を認められてなかったと。皆さん、
PV was not allowed to connect to the grid line. But today, it's quite common to connect a like a PV generated electricity to be sold to the grid. But before 1990s, battery was required for connection to the grid, or actually to be more precise, those a residential photovoltaic system was not allowed to connect it to the grid. And we thought that this way there will be no wider usage for the PV. And so we approached METI to ask for the arrangement so that we can sell electricity when there's surplus, and we can buy electricity when there is a insufficiency. And so actually we make requests which was like in a way lopsidedly favorable to our side, but leaders of the METI at the time understood the significance of it, and they worked with the power companies, and this became possible. This is quite common at this moment, but Japan was the first country where all the 9 national or the wide area power companies accepted this. Germany was an example where there was a sporadic example, but this was it happened for the first time in Japan, and this was another outcome from the Sunshine Project. So surplus electricity was purchased throughout Japan, and as an outcome, once again, of the Sunshine Project. So, with the necessity for creating a model or example, I decided to do the demonstration test with my own house 30 years ago. This is the photo from the time. This is my house on the left-hand side. So you can see that at the roof and the balcony, I could install the panel. I'd like to show you a video which was taken by a drone. So south side, west side, and the balcony are equipped with the cells. So like this, the installation was done. Now the flow of the electricity, well, this is something that you know. When there's surplus, we'll sell to the utility, and when there is a shortage, we get power from the utility company. So this arrangement was done in Japan ahead of other countries in the world. Well, actually, I have to be mindful of time. But at the time, there are so many requirements, like a requirement for the protection gear and such. At the time, if you can see the red box portion, I asked METI for help so that we can change many policies or regulations.
にしてもらったと。
And the model certification or model approval scheme happened, and this model was spread throughout the world, and we marked the 30th anniversary and such, so that everybody can know about those efforts. And this is very important. I think this data is unique to the world. This is the data for over 30 years. So power generation can last 30 years, and that was proved by this example. And yearly degradation rate was a 0.44% for 20 years, and after that, 5.96%. And this is a detail. With the interest of time, not going to be able to go over the details, but surprisingly,
93%とか
80% or 93%. So there were 38 modules. They were all analyzed. And I'm sure you're interested. So please look at this portion.
の対応
So the detail is included in the article or journal of the academic academy for the solar. So if you're interested, please look at this figure. I'd like to go to the last portion. So over 50 years, we were able to improve the efficiency, and the NEDO's target is on the left bottom side, 7 yen per kilowatt hour. And the duration is 30 years.
する可能性が十分ある
So I believe that this is quite realistic. That's what I like you to understand. And from now on, there will be many subsidies started after that.
これが京セラさんがヨーロッパに輸出
And this is what Kyocera exported to Europe. This is important. As explained by the agency earlier, Japan was number one, but the subsidy was terminated. And with that, well, actually, at that time, from around 2005, China worked on solar generation and production of cell and as a national plan, and we fell behind.
タリフ
And feed-in tariff in Germany, that was a great
これがインドの
initiative, and that spread globally. And this is a 1 gigawatt China project. And also in Japan, after Fukushima accident, nuclear power plant's accident, FIC project was implemented in Japan. When we look at the world, 1.6 terawatt. Kilowatt is a 1,000 gigawatt. 1,600 gigawatt is the global station. But in Japan, as shown here, just 9 gigawatt or 90 gigawatt is the figure for Japan. 80 gigawatt with the assumption of 8 gigawatt. About 38% of the peak power demand of Japan is now being covered by solar. Now, the crude oil import reduction is described here. 14 trillion yen over 20 years. Or with 30 years, the volume will become higher by 50%. Lastly, I'd like to talk about the initiatives by Japan.
カーボンニュートラルの
So there is a declaration or pledge to achieve carbon neutrality. And as explained by the Honorary, this is the targets for Japan. Currently, the lowest cost one is 5.11 yen per kilowatt hour. That was a bid price for the spring in 2024. That was the lowest price. And looking back at the Sunshine project and like to think about the significance for the national project, what I think is that the project was a great one and the outcomes are made. And the contributions, and actually it benefited not only Japan, but there was a big contribution toward the solution of the global challenges. Well, there are issue of the industrial competition, and toward the carbon neutrality, there's an even higher expectation. Now, there's a plan to make the cost of the hydrogen for 1/5. Now, Sunshine Project aimed at reducing cost to 1%, but the hydrogen just 1/5. I think this is quite doable. Lastly, with the interest of time, I'm being quick, but I'd like to talk about future with you. Can renewable energy cover the world's energy needs? This is what I proposed 35 years, Genesis project. So you can see red dots by distributing cells in the deserts in the world and connecting them with the superconducting cable. The power from when Japan is in night, the power can be sent from Africa when it is daytime. You may think this is like a dreamlike, but what is important is the following. I'd like you to understand this. What is the needed area for this project? Just 4% of the desert of the world need to be covered with the solar power. I'm talking about the primary energy, meaning that the entire energy demand can be covered just by covering 4% of the desert of the world. Step-by-step approach was the approach I was thinking about. And I'd like to also talk about hydrogen society. Currently, 20% is the conversion efficiency. At the time, 10% was the assumption, but currently 20%. And for the electrolysis, the maximum efficiency is about 70%. So from solar to power, 10%, electrolysis, 70%, and from hydrogen to ammonia, let's say 50%, which is quite ambitious. But with this assumption, just by covering 12% of the global desert, we can produce a necessary ammonia to cover entire demand. Lastly, I'd like to show you a video. Energy concept for 21st century Genesis project is a project to distribute solar power generation facilities around the globe and transmit the power using superconducting cables from the day world to the night world. Just by covering 4% of the Earth's deserts with solar cells, world's energy needs can be covered. This truly is a planet-sized project and is getting great attention from around the world. This grand project has already taken the first concrete step. The first step to realize the Genesis project is a local network of private residential photovoltaic systems and other elements. By expanding the local network to a global scale and network them, the Genesis project is materialized. So please do remember this video. Beautiful plant of order, the earth, without harming the environment, people all over the world become happier. To make that happen is our dream. So with such dream, towards new 50 years, please do carry out the development of renewable energy technology. With this, I'd like to conclude my lecture or presentation. Thank you very much.
桑野先生、ありがとうございました。
Thank you very much, Professor Kuwano. So on behalf of the floor, I'd like to ask a question, please. So Japan's solar power?
と超えてきて、
Now, more than so, it's the outcome of Sunshine Project. But what were the challenges that you face, and also what is the lesson you learned that you would like to share with the next generation human resources? And you also mentioned that we won in terms of technology, but we lost by business. And how can we change that? The perovskite is what we are to be working on going forward. And as was mentioned by the director, the technology development alone is not enough. We need to commercialize them, and we need to nurture them as industry. And the many consortiums have been developed in Japan under METI. This is important also. And actually, the people of Japan need to support them, the efforts. And Sunshine Project 50, Sunshine Project was able to continue, and that was because of support by many of the Japanese people. And also, industrial policy is an important element as well. So we were falling behind China. That was mentioned by the director of the agency. But China is in a way smart. They purchase equipment from Germany, and then invested a large amount of the funds. China does not have a natural resource, so they want to come up with their own energy source, and surplus is being exported. And not just the cells, but the same story is happening with semiconductor today. When it comes to all important technology, what I believe is that they need to be supported by national industrial support. And this does not require support from METI, but the support from population is needed. Of course, the government agency need to serve as a key agent, but for important technology development, I need to be worked on as a national project backed by population. Thank you very much. Let's give a round of applause.
NEDO